Now I can hear you.
Hello, everybody. Should we start?
Yeah, let's start.
Let's make a, make a Dropbox paper just in case we want to type things.
Yeah.
We will. So this is like name resolution, salsa brainstorm. I'll fit this to the channel.
Are you pasting the link somewhere? Oh, here it is.
So, yeah, so where should we start? So, Alexia, I was reading your description, and I mean, one thing I could explain. I don't know. I'm not sure where to start. I could explain a little bit how like chalk handle cycles of this kind, which I think fits your description somewhat. I think maybe relevant. Or we could just talk about. I think maybe the best place to start is actually mapping, rather than being totally abstract, talking about the actual problem, like how you got to that simplified description.
Yeah, I think maybe it's even makes sense to take a step back and speak a little bit about like name resolution in general and why do we want to do this talk. So yeah, let me just describe what we're trying to achieve. We would like to have name resolution to be incremental, and it's probably makes sense to ask why do we want it to be incremental? Because, for example, in something like IntelliJ, name resolution is not incremental, but it is not incremental because it is on demand and really easy. Basically, in Java, every file has this package directive, and you import stuff using fully qualified name. So IDE can basically maintain a mapping from fully qualified name to a class object in its internal presentation. And this mapping is is very easy to update after file changes. So in IntelliJ, you basically resolve names in this map every time you need to import something. And if you resolve names locally inside the file, you can just basically resolve all of them because it's usually not that much of work anyway. But you can also imagine like lazy solutions which resolve name only in single function or something like that. Basically, you can be trivially lazy. In Rust, it seems to be that we can't really be lazy with name resolution inside a single crate. We must name resolve the crate as a whole. And when I say name resolve, basically name resolve all the imports, like not name resolution inside item bodies, just like top level stuff, because macros and imports need this fixed point iteration algorithm, and it's completely unclear how to make that on demand. Because this seems like it could take a fair amount of time, we need to make it faster and we need to somehow incrementalize it. One way to incrementalize it is to memorize macro invocations themselves. Basically, if you expand this macro using this input token stream, you just memorize it, and when you expand this macro in some other context, you just take results from cache. This seems like an easy part and also a required part because procedural macros can be arbitrarily complicated. That leaves us with resolving imports using this fixed point iteration loop. And I think we should incrementalize this as well, because it's actually the code which works in Rust Analyzer now is pretty fast. It's like tens of milliseconds, but it's like not super complete, and even tens of milliseconds is like something you could spend computing type inference or stuff like that. Like, I think for completion, the budget is about like 100 milliseconds, but even 100 milliseconds is already a noticeable, perceptible delay. So like the ideal budget would be like something like 16 milliseconds, a single frame. So like tens of milliseconds is something which is worthwhile to save. The strategy, which I think could work for making this incremental, is to detect when there are no changes on the top level. For example, when you're typing inside a function, you ideally don't want to invalidate the whole name resolution, because all the modules are the same, all the imports are the same. You maybe need to add some imports inside the function, but it's not a whole import, so you can just resolve them eagerly. Yeah, so here's the basic idea. In Salsa, we set up the query in such a way that it looks only at top-level items, and it completely ignores bodies. And that means that like typing inside the body is okay, and name resolution is reused. And this actually is implemented and works quite well. So when you type something inside the body, name resolution is instant. When you add a new import, you still got completions for import. These completions are still basically instantaneous, but they rerun name resolution from scratch for the whole crate. And the problem where this approach falls down is macros, because so a specific instance where we recompute name resolution, but where I think we could avoid recompute name resolution is when you have some item which is decorated by a macro, so something like lazy static. And inside this item, there is item's body, and you type something inside the body of the item. Ideally, you should maybe expand this single macro, understand that the set of top-level items is the same, and avoid recompute name resolution. But currently, when we compute the set of top-level items itself, we include macros with their bodies in this set. So if you change macro body, you change the set of top-level items, and you have to rerun the whole name resolution, even if the result of macro expansion would basically be the same from the point of view of name resolution. Yes, I think this is the statement of the problem.
Okay, so to reiterate, so first of all, we really want to reuse the expanded form, or we want to avoid re-expanding macros. That's what we're saying. That's like in terms of work we want to re-avoid. And one thing I didn't understand, when you said that the macro and its body is included in the set of top-level items. So if you change the macro body, then you'd have to rerun the resolution. Is that right?
Yes.
But if you're changing the body of some other function, you wouldn't. Right? It's only when you change the contents of the macro.
Could you repeat this, please?
It's only when you change the body of the macro that you would.
Yes, you change the body of the macro, but like macros like could be big. Like you can imagine some like procedural macro which decorates a function, for example. So typing inside this function is basically typing on the top level.
So why do we think that we could avoid? I mean, when you do change the body of the macro, we are going to have to re-expand to see what its result is.
Yes.
Because it might be different now, right?
Yes.
And is your idea that after you re-expand the macro, you can figure out that indeed type resolution didn't need to change? Or sorry, name it.
Yes. Yes, so like lazy static example is a very good example here, because if you change the definition, how you initialize the lazy static, you like don't change the name of the static. So from the point of view of name resolution, this is actually a no op change, nothing changes.
Okay, so in the doc, I'm going to try to write this out a little more specifically. So one scenario would be like we have a lazy static. I don't remember how the syntax is, whatever it is. Static.
Let me copy paste example.
Go ahead.
Here we go.
Okay, so you're saying, right, so the change is to alter this line.
Right? Yes, basically uncommented.
Yeah, and so that doesn't need to affect the name resolution. So let's agree. That makes sense. And okay, and so the challenge you're finding, so what you would like to have, if I understood, is some way to say, basically, some way to say, we had like a top level query that was like name resolution results. I don't know, I'm sure it has a different name. That's kind of the full name resolution or something, which kind of gives up a map with like identifier to ID or something. Just close enough to true. And then in the process of figuring these out, this is like a fixed point process of some kind, right? In the process, it invokes like expand query. Let's say this has ID L0. It would sort of say, hey, expand this. Sorry, not expand query, expand macro invocation, something, right? And the problem is this in turn uses name resolution results, right? Really, I suppose this is also parameterized by like probably a module or something.
By crate.
Okay, by crate, sure. So this uses those results. So now we have a cycle, right?
Yes.
Is actually so, the expansion uses those results? Or figuring out which, not really, I suppose. It's figuring out which definition lazy static refers to.
Yes, so it does not like actually takes an ID, no, it takes an identifier lazy static.
Okay, so to figure out what lazy static refers to. So there's a query you're saying? That's like, the code as implemented today probably does this internally.
Yes, it is not a query because this runs inside this like general fixed point loop. So it just looks up in this map, which we are currently building.
Mm-hmm. And so then it would invoke like, let's say we figure out what it refers to. We use the map we are building. We get back the ID of the definition. Let's call it D0. And so then there's a query that's like expand macro invocation D0 with the arguments from L0, I guess, let's say.
Yes.
I mean, probably, I don't know, maybe it takes tokens or something. But, and that query, though, doesn't recursively refer back to name resolution, right? Or does it?
The expand macro invocation query is all good. Now, it doesn't need to refer to name resolution. But like this actually is important. What are the arguments to this query? So like if we actually pass token tree as an argument, we need to have this token tree in this name resolution results query. And that means that we depend on the actual token tree and not on the results of the expansion. So we could pass an ID here like the ID of the macro. And this actually what makes it difficult, because you need results of name resolution to assign this ID. So for example, okay, in the simple case, this lazy static is a macro in a file which is typed by the user. So an ID could be a position in this file. And this would actually work for one level. So
just to be sure, when you say the ID, you're referring to the ID of the macro definition or invocation?
Invocation. So like the idea of macro invocation could be basically a position in a file, maybe like relative position or some path, like so it can not be invalidated on changes. And this would work for one layer. But say this lazy static generates another macro, generates something which invokes another macro, and we need to expand that macro. And we somehow need to identify that macro. And kind of to understand the meaning of that ID, you need to know the results of invocation of the previous macro. And to know that, you do need name solution, I think.
I'm trying to decide if you do. So you would need, what you would definitely need, it seems like, is the ID would have to sort of tell you how to recreate the input, I guess, right? So
Yes.
like, so for one level, so really then I guess what the question is like, what does the ID map to? In other words, I'm thinking of, remember the Salsa intern in RFC, for example, where the ID could be, as you said, like the base IDs are sort of some path through the input to some bytes or something. I guess you can just think of it as a file line column for now. That's like the base level. And then the next level would be like a span into the result of a macro expansion, which means we would need two other IDs to identify it, right?
Yeah.
And that seems like it covers all the cases now. So there is, you're right that name resolution plays a role, because figuring out the D in that macro expansion, that the definition, that's like name resolution's job. But given a definition and an input, you can sort of unroll it, right?
Probably, or no.
I think you could, but I don't think this would solve your, so I think you could say, okay, I think you could make an ID that maps to something like this, the way I wrote it here. And the idea would be, if you have to, let's say that the lazy static is inside of one macro A that generates an invocation of another macro B. Then what would happen, let's see, macro A expands to B bang something, right? You would wind up with, first you would invoke like expand macro invocation, A definition, A use site, right? And this use site is just a base position in a file somewhere. That would give you some set of tokens, which are part of the Salsa database. And then you would ask for, okay, now I would ask for like, now I might say, later, I look at those tokens, I see B bang, and I say, if I make an ID, right, which I'll call B use site, that corresponds to that pair.
Yes. Yes, I think actually this might solve my problem. The problem was that in my implementation, I used there's some
my daughter's drawing. How can I do?
Okay, so in my implementation, I used only use site as an ID. Because like in theory, given the use site, you can get to the definition if you invoke name resolution, because like it's a use site. If, however, we actually put definition of the macro into its identity, this seems like it could just work probably.
Wait, but can I ask something? What does expand macro invocation return? Because if it returns the full token tree, doesn't that invalidate the whole query anyway? Every time we change something?
Right, so I think you could do something like what I'm showing, but I think it may not solve your problem. So let's see. I just realized that.
Yes, I now understand that this is at least a partial solution due to the problem that Florian said. Because like really, we need to put some kind of extract top level items between expand macro invocation and the rest of the name resolution. Maybe.
So, yeah, I mean, the problem is that expand macro invocation, right, it returns the full set of tokens. So in principle, you could have a layer in between that sort of extracts out the stuff that name resolution cares about, which is like the definitions that result from a macro invocation or something, right? And
yes.
And if you did that, you might well find that the full name resolution becomes reusable because you have like name resolution, which directly invokes like definitions from macro invocation or something. A use site, which would, I guess, this would probably return back. This would have to, maybe definitions isn't quite the right term, but it has to include also the macros, right? That need to be expanded further. But I think this ID should be relatively stable. Like it would return back the use site basically.
So, yes.
Which hopefully didn't change. I guess like actually using spans isn't probably great, but if you had a more stable form of identifier, then and then this would say, okay, then we would invoke definitions from macro invocation. We would figure out the name, we would somehow do this. And that point would be that while the results of expand macro invocation are dirty, the results of definitions from macro invocation would be clean.
Yes.
So you would re-expand the macros, but you wouldn't, or some of them. I think you could do something like this. It feels like it could work. And in fact, like it feels sort of nice because having a weight, you want some sort of ID for the text in a macro that just on its own you can sort of trace it back to recover that text. You know what I mean? That's kind of what this ID gives us. I think what this solution does not give us is the ability to have finer grained reuse within a crate if we think we want that. Like right now you are doing name resolution across the entire crate, and maybe we would like to be able to say, within this module, nothing changed, so I don't need to recompute anything, you know? That's a little bit complicated because of the interdependence between modules.
Yes, like my hope that like that probably is a point of diminishing returns. Like if we can get reuse across not typing on the top level, that's probably fine.
Yes, I think
like at least based on what performance looks like right now, that would be just awesome. We will have instantaneous completions.
Right. It seems like if we're careful with our choice of intermediate queries, right, then the only time you would have to rerun name resolution is when you add a new item, or when you change the name of an item, or in some other way like this, or add a new macro invocation at the top level. And that is probably unusual as it comes down to it. And it's not that slow.
Yes.
All right. So if I understand correctly, what you're trying to do is if the outermost macro invocation changes, then we hope that the innermost one doesn't change because it's cached by the query system. Is that right?
It's more like the set of definitions created by the macro don't change. Like the actual macro expanded token tree probably will change. Well, that's the whole idea. It is changing. We know it's changing. But
sure. But the innermost ones are cached because they hopefully don't change the invocations.
Like the invocations themselves, like what this token tree expands to, given this micro definition, is definitely cached, and this does not seem like a hard problem because, well, you basically cache it and that's it.
Okay.
But I'm understanding that the set of names which are the result of the name of the invocation is the same. Seems harder. So basically, yeah, the inner macros would just be reused if they resolve to the same macro.
Yes, I think that's right. And I think what this would do is, well, like any macro whose definition changed would have to re-expand. That seems unavoidable. But as long as they generate the same set of IDs, the name resolution results themselves do not. The key thing would be coming up with the name of, like making sure the IDs are sufficiently stable. That is true, but I think the basic trick for that is to make the IDs a tree, right? So that you're not using like the offset in bytes or tokens through a flat list, because then inserting things in the middle of the list causes problems. But you have some tree structure to it, so that inserting things in the body of the lazy static doesn't affect the ID of the.
Well, actually, also the second trick which we actually use for items now, like the IDs are not trees, the IDs are positional. To identify an item in a file, we enumerate all the top level items and use the index of an item as an ID. So it's like kind of not really a tree structure, it's a positional thing, but you carefully arrange so that positions don't change often.
Yeah, this is a similar trick. I think it's
that sounds like it's changing when you format or the file, for example, because then the positions change, but the structure doesn't really.
Right. The ID comes out the same, but the thing that the ID maps to changes. I think it works to be the same, regardless. I don't know. Seems like it could work. That would make me happy. I do think at some point we could accommodate this recursive invocation style, but I don't mind putting off the day of reckoning a little longer if we can do so. In short. Want to give it a try, Alex? Do you feel satisfied?
Yes, I think I feel satisfied. Well, at least I want to try it. I'm not sure that I don't actually hit a wall somewhere in this plan, but I don't see problems before implementing it. Actually, if somebody else wants to dig into micro expansion and resolution code, feel free to join. Like I will be happy to work on something else. I like doing diagnostics now. It's also very exciting.
I would love to, but I don't think that's a very realistic suggestion, so I'm not going to make it. I know I will say I will and will not. See where it goes. I would be, the best I could do here, which might be useful, like it might be worth trying to play with this in a smaller example outside. I don't know how I have never actually worked in bus analyzers. Maybe it's small enough that, and you're familiar enough that you move pretty fast. But like for me, if I were going to try to prove this out, I would make a little standalone thing and toy with it, right? But yeah, that's mostly because I don't know Rust enough.
So there's one thing I want to talk through is that how does this work with macro by example? We are defined like as you parse the crate. So like what would be a D for macro by example? Is it the intern version of basically the document tree which defines the macro or something else? Can it just be the ID itself?
I thought it would just be the ID. I'm not sure I understand what makes that case harder than the other cases.
Yes, okay, yeah, I think that the ID would work. I was under the impression that like you really need to intern the macro bodies, but it doesn't look like this. Okay, so we probably can do this here without that interning branch of Salsa.
Probably. I think the interning branch is probably ready to land regardless, but and toy with. But maybe it would be nice if we could keep that a little separated, I guess. I do think that will be a really powerful enabler though, for this sort of thing. It's exactly the kind of case where it's useful. Because you need some way, but I mean, you could, the interning branch, ultimately, you could always, like, it's really just useful for constructing these sort of complex identifiers, but they could always be built out of RCs and stuff.
Yeah, like we do have interning already. It's just like handwritten and no git CFO.
Right. So it doesn't really enable anything you can't already do. Just makes it a little nicer.
So I think that is it. Like,
cool.
I'm satisfied, more than satisfied.
Well, let's see what happens. Yeah, I mean, try it, see what roadblocks you hit, and we'll reevaluate. Thanks, y'all. I guess I'll close.
Okay, bye then.